Hi, today I'm gonna start to talk about the truss. Truss is kind of the structure that is built from slender member that form a series of triangle. In other words, if you look at the truss, you will see that the series of triangle connected together to create an structure. Uh, there are many applications that you will be seeing around. If you go, there are several bridges. They use a lot in the bridges to make a bridge from the truss. Also, there are there's the residential houses that if you go there, they use the truss to hold the roof in place. Also, if you go to the big box stores or the warehouses, most of the time when you see the warehouses or the big box stores, you see the roof. There's a structure beneath the roof that hold the roof in place, and that's the truss structure. In most cases, so you've seen the structure is going to be similarly look like this. So I will just draw a very simple one. So you will see a structure like that, that's got connected, series of triangle connected together, and it might be a bridge that holds it in a place. That it might be the roof of the warehouses or the roof of the houses or any other structure. It uses it a lot. There are a couple of advantages that this structure has. One of them is that it can withstand a very large load. So sometimes you see that there's a competition. They build a truss from spaghetti or from the popsicle sticks, and with as you can see presented, if you look at it, the spaghetti bridge is very thin, slender members of spaghetti connected together as a triangle, and it can withstand a heavy load. Also, the other advantages of that is that it can be built on the very large span. So if we have the support that needs to be separated from each other in the long distance, this is a very good structure. One of the reasons used in the for example the warehouse is that because you don't want anything to be in the middle of your warehouses. You want the roof goes from one end to another, and so you use the truss to hold the roof over the very large distance. It also has disadvantages. For example, one of the disadvantages of this is it's gonna become very heavy. It can becomes heavy. Also, if you use, for example, for the large bridges, it needs lots of inspection throughout the year to make sure and go and inspect every element of the truss to make sure the bridge is not in danger of collapse. So every element should be inspected. There are a couple of main assumptions when we are working with the truss that we have to consider. The very first assumption that we are using here is that we assume all the loads applied only on joint. So all the load would be applied if there is the joint that connect the members together. Loads only applied on joint, so there is no forces applied on members. So we don't have any force only on the joint. So the force are applied on the joint. The second assumption that we have is that all the joint behave as a pin. So there are a pin, so all the members connected to the joint by a pin. In other words, because this is a pin, it doesn't restrict it from rotation. So all the member can rotate about that joint. But because the pin doesn't let it go left or right, it doesn't let it go up and down. So there's the pin hold it in a place, it doesn't let it move, but it lets the members rotate. So there's a two first assumption. First, all the loads applied on the joints, and all the joints are pin. So these two main assumptions we have. Now, if I assume I have, I draw a very simple truss that has three members, and it has, for example, A, B, and C, and it has it sitting on the supports. And there's a force applying on that. For example, C, let's say there's a vertical force applying on that, F. If I look at that, if I look at this triangle, the truss, if I disassemble it and remove the parts separately, so assume I bring out the part AC, so I will take out the AC, so I will bring the AC out. So it's a joint A, it's a joint C. In that case, if I look at here, there is no forces applied on the member. I said that all the forces apply only on the joint. So all the forces here, whatever forces we have, including the internal force and external force, will be applied at A. And all the forces we have, including internal force or external force, would be applied on the C. Everything is on the joint. So if I look at it as I bring it out and I put the external force on that member, that one member, I would have two forces apply on that, and if you assume I'm calling it, for example, P. So assume there's a two internal force applying there. So there's a P here and there's a P here. Assume it's like that. If you look at it, it's a member with two forces only apply on that. There's only two forces apply on that member. Remember previously we were talking about the members with two force member or three forces member. This is a two force member. If you remember when we were talking about the two force member, the only way that the two force member can be in equilibrium, if I assume I draw a two force member, something like that. So let's do, for example, I call this A and call this B. Remember, the only way that the two force member could be in equilibrium was that, first of all, the forces that apply are equal and in opposite direction. So if this is P, this should be P. And also they should have the same line of action. They should have the same line of action. They should be equal, they should be opposite. So here, this AC is going to be similar to that. So we have the forces apply at A, the force apply, so we have only 2 points is that the force applied there. So the forces should be opposite. The forces should be equal in the magnitude and also should share the same line of action. The only way that the force at A and the force at C can share the same line of action is that both of them be along the member. That's the only way it's going to happen. So if this is a P here, this is going to be a P here. So both of them should be along the member. If they are not along the member, they cannot share the line of action. The only way that they can share the line of action means that they should be along the member. And by knowing that, that's what we know, that by knowing that it means that all the forces in truss, and remember that all the forces in truss are along the members. Every forces in each member of truss is along that member. That's how it will be. So that's also we need to always remember that the forces might be in compression or in tension. It can be both of them. So if I for example, if I go ahead and draw I assume I have two member, I draw the AC again. So assume this is the AC again. So it might be in compression. It means that the internal forces in that member is pushing it. So it's going to be like that. So if this is the case, this is the member is in compression. Or it might be in tension. So if I have the same point, same member here, but this time instead of the force pushing it is pulling it apart, then it's going to be in tension. So it's going to be in compression, it's going to be in tension. Remember again the points, there are equal and the opposite and along the members. They are equal and opposite along the member. If they're pushing it, it's compression. If pulling it, it's going to be tension. So this is the tension. This one is the compression in truss. So one more time, the assumption we made is that first of all the forces only apply on joint. All the joint are pin, so all the member connect by joint as a pin. So there is no moment at each of these joints. Also, if we take out member by member, if we disassemble the truss and take out member by member, the internal force is gonna be always along the members. It might be compression along the member, or it might be tension along the member. It might pressure push the two ends toward each other. It's gonna make it compress, or may pull the end away from each other. It's gonna make it tension. So these are the two cases we have. Most of the truss that we are working in statics are the simple truss, and the simple truss are the truss that are made of a simple triangle, and then the elements add to that simple triangle over and over again. So I'm going to start to show how we can make a simple truss. So for example, the simple truss is built. First, to build a simple truss, we draw a triangle. So it always starts from the triangle, a simple triangle. So we have a triangle. Then at every step, we only add two elements and one joint. So that's how we're going to work that. So I'm going to add two elements, one joint. So two elements, one joint. This is still a simple truss. Again, I'm going to add two elements, one joint. So it's going to be two elements and one joint. Still is a simple truss. I'm going to add two elements, again, one joint. So two elements at one joint. So it's going to be simple truss again. And I can add again two more elements and one joint. So two elements, one joint. And then I probably would have something like that. So this is a simple truss. We start from a triangle and add two elements at the time to make it. We can work with different shape of triangle to get what we want. For example, we can start from triangle simple like that. So again, we have a simple triangle, and then we add two elements every time. So I'm going to add two elements. So it's going to be two elements, one joint. Then I'm going to add another two elements. Then I'm going to add another two elements. And I can keep going and add elements and elements. So this is also still a simple truss. So I can work with that. Another form of that. Assume that's the final shape I want to have. So I start with a simple. Again, I start with the simple triangle, one triangle. So I start with the one triangle, then I will add two elements to that. Then again, I will go ahead and add two more elements to that. So I will come here, and then I will go ahead and add two more elements to that. So I will come here, come here. So this is also a simple truss. We start with the single triangle, add two elements, two elements, two elements. Each step we only add two elements. So we get still what we get is the simple truss. That's how we build a simple truss. So throughout this section, we are going to learn how to start and analyzing this simple truss. And remember, every time that we are talking about analyzing truss, mainly we are talking to find the forces in each member of the truss. So that's how we analyze truss. We look at the truss and we try to find out how much force is is in each element of the truss.